Hello, my friends. Welcome to my lecture. Well, today we'll speak about IP addresses hierarchy. So we'll find all solution for that. With IPv4 and IPv6, it will help us to improve our skills about these IP addresses. Well, I'm looking a little bit different, but thank you so much. I don't have some concern. So just when I find time, I'm running to here to make these videos anyway. Let's start with me. The Internet Protocol IP describes the use of IP addresses to identify Internet connected devices. IP addresses have a hierarchy that makes it easier to route data around the Internet. Write that. Many addressing schemes are hierarchical. Consider us US phone number, like we have +1, then 541, and 754, and 3010. It's like that. We can break that into four parts. Let's come here and take it left. I will go a little slow. Right to right to he. Yeah, right. Let's look. Do +1 is the country code. So for the Turkey it's 90. For India I think 91. I'm not sure. And yeah, many more countries there. Anyway, we can understand when we saw it. And also we have area code. Okay. In country now we are looking for area. Area code is 541. And local exchange, the another part of the place, this is 754. It's okay. The last one is specific phone. It's just representing it, right? Okay, let's go to here and read it again. The hierarchy makes it easier for the telephone system to efficiently send calls to the right lines. Well, for phone, it's same like that. 1 minute. I will make. Yeah, friends. Someone just give their hands for like that, and for that I just close video anyway. So the hierarchy makes it easier for the telephone system to efficiently send calls to the right lines. The last place is that. Okay. Now we are going IPv4 addresses because we look for the computers, internet. Okay. Now we are looking for the phone, which is in for the phone we have same hierarchy, but we will look for the computer. It will be easy. Okay, for understanding. Yes, something a little bit different. So like IPv4, which is 8 power of 2, it will bring there 4090 possibility in one place. Anyway, we know it's between 0 and 255. But for the IPv6, we know this is 16 bits and this is how you gonna say like uh, is 16 power of 2. Anyway, let's come here. IPv4 address right here. Okay. Both IPv4 and IPv6 addresses are hierarchical. For simplicity, let's examine the hierarchy of IPv4 addresses. Okay, we have 24. I told you between 0 and 258, 256. What we have here, we have 24, 147, 242, and 207. Well, this is the IPv4. Okay, one, two, three, four. So it's 8 power of the 8 power of the 8 power. It's all the way going like that. Then we know all this will give us the possibility for devices like 32 power of 2. It will give us many more connected devices. Let's come down. Okay, the first sequence of bits identifies the network, and the final bits identify the individual node in the network. So what I'm saying that IP address could break down into these two parts. First sequence of identifies the network. Well, Comcast network. This is the big part. This is like one place, and a home computer is the another part. Okay. Now we will go the details. Let's say The first two octets, we're calling it octets. Okay, octets is like um, 16 bits. Okay, like octets, hexadecimal, but we be calling it two octets. Is one octet is 8 bits, like 8 bits is we're calling it like that. Two octets mean like 16 bits. If we want to say hexabits or hexadecimal number, it will be 16 only. Identifies a network administered by the Comcast, an internet service provider, which is displayed. The last two octets, the final 16 bits, identifies a home computer on that Comcast network. Well, this is the hierarchy. Look, this is Comcast network. This is another place again here. So if this number, the two octets, if happen like 242 and 235, no, 215, it will be in 24.148 network points. So it will be different hierarchy place. Anyway, you can see what we are calling. This is the big map. So all this there some computer. Okay, two computer, three. So we have here 10 computer connected to this Comcast network. Yeah. If the last two octets were different, then the IP address would point a different computer on the Comcast network. If the first two octets were different, then the IP addresses might belong to completely different network administrator. The Internet Protocol uses a hierarchical addressing scheme to make it easier to route messages from source to destination. Once a message arrives at the network, a network router can take care of sending the individual node. The next lesson on routing device into more details on how that works. Now we will speak about subnets. It will be amazing topic again. Yes, now let's look for the subnets. Network administrators can break IP addresses into further subnetworks or subnets as needed. Starting with this IP address, which is we called again Comcast network, and especially your computer IP will just come down. Okay, that could break down into three parts. Well, it's changed now. Three part. We will look for three part. We will check now. We will look details of this uh, IP address. What's different there? Well, the first two octets will be unique network. Okay, the one octets will be medicine department. Continue of the 213. The another place, the 13 will be lab computer. So 14 can be lab computer, 15 will be lab computer. Maybe this 128 also will be medicine apartment and other things. Okay, this is not important for now. Just you need to understand how we are separating all these IP addresses into hierarchy. Okay, the first octets identify the entire network for the University of Michigan. The third octet identifies the unique medicine departments. It's all connected to each other in one way. Okay, this like you can think this is child, this is father, this is grandfather, like that. Well, and the fourth octet identifies an individual lab computer in that department's network. Adding further levels to the address hierarchy can improve the efficiency of routing within the network. Let's check your understanding. According to the breakdown about which of these IP addresses identify competing devices in the unique medicine department network. Well, what we saw there. Look, in that point, you need to see all this coming medicine department. But first place, what we did there, I think this one, right? But what happened? Look, where is it? It's okay. First we start like that, Umic network, and we put there 128 that, then the lab computer. Let's go there again and do same thing, okay? Like, where is it? Yeah, this, look. look, you need to careful, okay? Yeah, because this is not that. It's same going here, it's same, and look, this point will be different. What do you think? All is starting with 142 and 141. Let's look what's starting there. How starting it's there. Um, Last time I will go there for you. Okay, yeah, it's starting with 141, right? 141, and let's go here again. Where is that? Oh, I forget it. I lost it. Yeah, 141. Then it's going all the way like that, and this one is true answer. Okay, this one. Look, this is that. You need to see this detail. It's going all the way like that. Don't confuse. Here we have 13. Just don't confuse about 13. Okay, just come here and see this 141. Okay, and see 213. So this one, and let's go 128, and this one will be our possible answer. Okay, just don't confuse from here. Let's take it. Let's do it. This is the answer. Okay, don't confuse from this place. I think I didn't do wrong. 100 441. Right, it's true. Let's calm down. Splitting octets. Well, yes, my friends, now let's look here. Splitting octets. In actually, IP addresses are often split in the middle of the octet, which is, we'll see now anyway. Um, to understand how that works, let's represent the previous IP address in binary instead. Well, 141, if we look in the binary, we will see that, right? We know how to calculate, right? I think you know. Okay, don't worry about it. It's 1, and it's 4, 5, it's 10, it's all the way going like that, okay? So then it will be 141. Well, just look here. This is 213, this 227, and the another place is the 30, okay? Well, this is computer language, okay? Computer knowing all these things, like in binary, they don't know decimal. Okay, let's come down. How we can separate for the computer language this all things like, okay, we know how to separate this IP addresses for ourselves for our decimal system, but let's look for the computer how it works. Okay, altogether that translates into these 32 bits total. It's 32 bits. They are coming next and next. Well, it's just they are spreading there. Let's look here. All is next and next now. We'll go down. The first 16 bits could route to all unique. So, I mean, I think until here, I'm not sure. Anyway, later we'll look at the next two bits. I think 1 minute, 8, and all the way like this point. I think yeah. This point. I think this point is 2. Maybe I can draw it, but it's not important also. Okay, this point is uh, wrote the specific unique department, which is we saw it, right? And the final 14 bits, the 14 bits from this place, is representing individual computers. So we have many more possibilities there, you saw, right? Okay, let's go. Oh, where I'm going. Just tag to this back to there. Okay, let's come down and let's look here what we have. Oh, maybe I need to go a little right. Okay. The hierarchy. Let's. Okay. Look here. It's we do same thing. Medicine department, lab computer, again same methodology. What we do into the decimal system. What is different here? Just we separated a little bit differently. Like not we didn't put there something like 227. It's so 127 like that. Well, this hierarchy gives UMIC the ability to differentiate between 2 power of 2 departments and 14 power of 2, which is we're talking about here. So we have four possibilities here. It can be medicine department, it can be um, let's say another thing, what, the computer department and then other department, office. But four things can be there. But here we have 14 power of 2, which is 16,384 possibility for the, so for computers there can be devices, computers within each department, splitting. So for each department, okay, don't forget it, for each department. For computers, it's like that. For medicine, it's like that. So 16,000. Anyway, splitting octets might seem confusing at first, but computers store the IP addresses as binary anyway, so it is all the same of to them. To them, where is that? As we've just seen, the ability to create hierarchical levels at any point in the IP address allows for greater flexibility in the size of each level of the hierarchy. Check your understanding. Well, check your understanding. But we know if the UMIC network instead used 3 bits to identify a department network, how many departments could they differentiate between? Well, just think 3 bits, what it can be. Okay, let's come here. If we have, uh, let's say 2 bits, if we say 2 bits, it will be 2 power of 2, right? It will be 4. Just there can be 4 area, like 4 part. So anyway, so if we say 3 bits, it will be 8, because 8 power, so 3 power of 2, it will be 8. There will be 8 places, 8 departments, and each department will have their uh, 16,000 devices. Okay, it's all like that. Well, let's say 8. The answer is 8. Okay, now let's go practice questions. Internet protocol. Yeah, let's come down. This is the question list. You can see practice questions. Okay, let's look. Which of the following kinds of computing devices use the internet? A tablet computer, desktop computer, smartphone, which is all. I think. Yeah, all have this IP addresses in their work system. Let's come down to the second question. In what situations in the Internet Protocol IP use it? In what situations is the Internet Protocol IP used? It is used at any time that two competing devices send data in each other in a computer network. Anytime? No, anytime. It is used at every time that two competing devices send data to each other over the internet. This one is true. Let's put it there. The answer is that. So this one is not true, I think. I don't believe. So also just put them two wrong. Okay, let's go a little bit up. Maybe we can put them for them. So that this one is true. Okay. So this one is true. I believe this one is true. It is used when a competing device is connected to the other internet connected device using a wired connection, but not when using a wireless connection. It's not true. It can be everything. It is used when two competing devices are transferring data over the internet, a low bandwidth network connection, but not when transferring over a high bandwidth connection. It's not true. I don't believe. It's not true. What happened? Oh, where is the third question? Oh, here. Which of the following statements about IP addresses is true? Which of the following statements about IP address is true? Any computing device that is part of a computer network has an IP address. That's true. If an internet user wishes to receive email, they must sign up for IP address. No. So, if an internet user wishes to receive email, they must sign up for IP address. Yeah, but in modern times, every computing device that is manufactured is assigned an IP address before it's sold. When data is sent between devices on the internet, they identify each other with an IP address. As an IP address. Okay, I will check and I will show you. Yes, friends. I was checking a little bit confusing questions. I think any computing device that is part of the computer network within our package, yeah, but it's a very following statement for IP address to recite that this is not true. I just checked the answer, okay? I'll tell you. But this one, it's modern times of computing device manufacturers design and blah 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 something. It is not true. The answer is D. Okay. When data is sent between devices on the internet, they identify each other with an IP address. Like what? It's sending information to here, like say from this IP address. Let's say. Okay, anyway, something like that. And it's tagging that this data, this it will be data, let's say this data, and it will send back to this IP address with another IP. So another things, and we can send here just think like five. Anyway, all is that. Thank you so much. The answer is that. True answer is that. Thank you so much for joining. Have a good time. Next topic will be what, let's come down to the word, yeah, we will look right here for the quiz. Yes, my friends, the internet quiz one will start another lecture. Thank you so much for joining. All we learned about this lesson, this guys, internet address and the questions, but this questions we did many more things here, right? IP addresses. Thank you so much. Have a good time. See you later. See you soon for the. So see you later. I want to see you there again for the quiz. Thank you. Bye bye.